in our booth the last couple of years, and he's a very, very good presenter, but he has some really interesting technology for us to share. All right? Thank you, Yossi.
Okay, good morning, everyone. I'm Yossi from SilabTech, and today I'm going to take you through a few things, few areas that we had observed changes during the last year, and I just want to keep you up to date about high-speed serial interfaces. Before we start, I'm just going to take you briefly across our products, where we are, and what areas we actually operate. So as I took an overview of our environment today, which include data centers and other elements, we are operating in a couple of different SerDes IPs, serial interfaces, and we provide solution starting from 10, 25, and 56 gig solution for data centers, USB, PCIe for different consumer application, we buy one, and DisplayPort for different other applications. And for the optical backbone, we have a solution for GPON and other optical interfaces. Today I'm going to cover a few topics. First is about customized IP. Second is about high-performance packaging. The third one will be how do we see standard bodies that are getting together. And the fourth one is about the JSD 204, which is an interesting standard supporting data converters. So let's start with the beginning. One of the trends that we see around is that standard IP cores are being provided to a wide range of applications. However, we see customers that come to us and talk about their needs to win their business, and their IP cores need a different performance, and we are working with them to customize them. So customers today are engaged in every aspect of the SerDes IP design to ensure that they can gain maximum competitive advantage. And this is something that is fairly new, because in the past we were very much observed customers taking an off-the-shelf IPs and using them as is, but they found that they cannot compete anymore. So in order to compete, we are providing a base IP, which is silicon proven, and when customers approach us for their specific application, we actually work with them to adopt the SerDes to their specific needs. So it could be the metal stack, the different VT flavors that they need, different reliability targets. If you know, automotives have different reliability targets than consumers, and different other aspects of the design. So don't try to take a square peg and push it hard into a round hole. We are taking this square peg and shaving it to fit the customer requirement. So this is a trend that we see in the industry, and I think as a customers, you should be very much open to leverage on this trend. The second trend that we see around is requirement for very short distance and very high throughput interconnects. And the solution is coming in the form of high-speed SerDes on one side and advanced packaging technology that is associated with this. So we see that there is a growing pressure for getting a power reduction on the main and largest chips available in the industry. And we see pressure on increasing the chip performance, for example, in the data centers and other high bandwidth application. And also pressure to keep the cost down, which means functionality that must goes into the high performance chip is must, but customers are looking on functionality that can be located at the outskirts of this chip and in a very close proximity, and by this saving cost and increasing the actual yield of the high-performance chip. And what I mean by this is that we have now technologies that we are associated with that are 25 and 56 gig serial interfaces, which enable 2.5D and 3D packaging technology. And what it's about new technologies of interposer, true silicon vias, and copper pillars that are coming from the foundries. So the foundry provide the packaging, we provide the high-speed SerDes, and together we can come up with very attractive solution. And we are actually addressing the top application, which is a chip-to-chip, ultra-short reach, like 1 centimeter away, no connectors, no packages in between. So this is a trend that we see coming up in the last year as the technology for the interposer is getting mature, and as the cost of the 7 and 10 nanometer technology is also very high, so customers are trying to disengage some of the functionality to a lower cost chips. The work that we've done this year is with a company called Fraunhofer from Germany. They had developed an interposer-based package with a true silicon vias and the copper pillar that altogether enable this functionality of a chip-to-chip high-speed interconnect. We have two potential standards that support it. One is the JSD 204 with its controller that enable today up to 32 gigabit per second, NRZ, non-return to zero type of protocol, and the OIF 56 gig USR, ultra short reach, which also enable 56 gig NRZ. These are the two standards that support this type of packaging. And overall, you can understand that the shorter interposer traces and the true silicon vias lead to improved insertion loss of a chip-to-chip interconnect at the high bandwidth. And since all of these devices are silicon-based, then similar thermal behavior of the substrate and the dies enable bonding technologies with very low pitch, like copper pillar, which in turn enable high I/O density of the SoC. So remember this image. This is going to be a key in the next few years in all the high-end solution. I'll quickly jump to the next trend that we see in the industry. Again, I picked one example, which is how different standard bodies are working together to bring up a unique solution that at the end bring high value to the end customer. In this case, it's the USB implementation form and the DisplayPort VISA standard body that work out the TypeC connector interface. In this interface, as I mentioned, two standard bodies have worked together to make a DisplayPort over USB-C protocol. So we have two standards running on the same connector and can interop with one another. And in actual fact, it's look like this. This is the TypeC connector, which you see today in many of the new tablets coming out to the market, where we have the USB 3.1, which is a 10 gigabit per second data lane associated with the red one, with the DisplayPort audio and video lane running an 8 gigabit per second and a USB power delivery. All of this is clubbed together under one connector. So this is how it's looking in actual life. This is the USB zooming in photo and all the accessories available around. As SilabTech, we are providing a very unique solution that is a very low power. The same SerDes can run multiple configurations. So in this case, the USB 3.1 and the DisplayPort will be exactly the same implementation, which is associated with a different controller. And this is how it's look at the end on your chip. So this is a complete GDS hardened with the pads, with the ESD cell, and this is what customer is getting from us in the end. This is an eye diagram of how a TypeC to TypeC link look like from the transmit side. And this is concluding the USB and the DisplayPort trend that we see. I'll go now to the last trend that we see, which is around the 204B. It's a JEDEC standard, which enable high-capacity data converters to interconnect between them and host processor. So just to give a rough idea of what we see in the market, we see the leading semiconductor companies coming out with very high resolution data converters, if it's ADC or the DAC side, with a very high, like 2 giga sample per second and more. With the current encoding scheme of 8 to 10 bit where the clock is being encoded, we are coming from a single converter producing 30 gigabit per second of data, which is a lot. So the standard is adapting itself to this new trend, and we see that vendors, semiconductor vendors that are leading the data converters market are actually highlighting the JSD204B as the main parameter that enable them to reduce the power of the overall solution of the discrete part. We are providing this as an IP, which include the SerDes and the controller as an integrated part. The simplicity of implementation with great flexibility via the link and transport layers of the controller is very important. So this standard actually aims to enable you to run quite a few data converters in parallel and avoiding disruption of one to the other and things like that. So the version B, as I said, enable you up to 12.5 gig using 8 to 10 bit encoding, and the version C, which is now under the final ink, will enable 32 gigabit per second per lane, 64 to 66 encoding scheme. So it's more efficient standard. So only 2 bits will be for the clock, and the rest is so only 2 bits is a payload on a 64-bit stream. So remember this. This is something that we'll see across all the new design of host processors and data converters. So whoever is doing 5G radio, WiGig, SATCOM devices, autonomous car, radars, LiDAR radars, all of this application will need to use this type of converter. And just to give you a sense how it's look on the measurement equipment. So this is a 204B running on TSMC 28 HPM. So it's 12.5 gig and 6.1 eye diagram. This is how our PLL phase noise look like. And the jitter performance with the mask that every standard defines. So this is the plot of the mask, and we are two order of magnitude away from the standard. So this is a very robust solution, very good, very much used in the multiple lanes, 8, 16, and 20 and more lanes together. And certainly we are the leader in this part of the market. Good. Thank you for being here. This is the last slide, almost the last. So just to repeat on the main takeaways, SilabTech offers customized IP that will fit exactly to your SoC, not just a general purpose, because we understand that with general purpose, you can have just a general purpose SoCs. Every project needs its own and unique tailoring. The second thing is that SilabTech is proposing 25 and 56 gigabit per second SerDes, enable the advanced packaging solutions. And the third takeaway is about the combination of different standard bodies coming with one standard. So I mentioned during the talk about the USB 3.1 supporting TypeC connector with the DisplayPort. So all the advanced display will need this type of connectivity, and we have the solution on a silicon, well proven. And the last thing that I concluded is about JSD which is field proven and is available as an IP.